Hello, protocols, packets, and programs. Next month, we'll see people dress up and discuss scary things. We'll hear horror stories and urban legends that just won't die. But thankfully, once all that cybersecurity awareness training is done, we'll have Halloween. Which means this week we talk with Francesco Cipollone about analyzing volumes of vulns and turning the conversation from prioritization to patching. Find a new trick and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Generative AI is powerful, but it comes with real risks, from prompt injection to data leakage misuse and agentic AI. The OWASP Gen AI Security Project unites a global community of expert practitioners who tackle these challenges every day. Together, they've built practical playbooks, adoption guides, and the OWASP Top 10 for LLMs, resources any team can apply right now to strengthen AI security. And it doesn't stop there. This is open source, built by practitioners, for practitioners, working together to secure generative AI. Visit securityweekly.com/OWASP to use the playbooks and join the effort to protect tomorrow's intelligence today. Tired of the endless cycle of cloud vulnerabilities? Avoid over 95% of CVEs with minimal container images from Minimus. No bloated base layers, no unnecessary packages, just what your app needs to run. Drop Minimus images into existing deployments to dramatically reduce your attack surface and remediation work. Maximum security, minimum effort. That's Minimus. Visit securityweekly.com/Minimus to learn more. This is episode 350, recorded September 29th, 2025. I'm your host, Mike Shima, and I'm here with a scary, something like that, John Kinsella.
As long as I'm not that, I forget the exact wording you used, but the thing that never goes away and is still alive. So,
John, the legend, and there's no urban to him. Yes, not an urban legend, just pure legend. If you also want to see some less scary stories, you could join us for InfoSec World 2025, October 27th to 29th in sunny, I think it'll still be sunny in October, Lake Buena Vista, Florida, at Disney's Coronado Springs Resort. Workshops run October 25th and 26th, and at the end, October 29th and 30th. The premier cybersecurity conference is here. Save 25% with code ISW25-SW at securityweekly.com/ISW2025. Or just go to our website. You'll be able to find it and not have to remember all those letters and numbers. The other thing I would like you to visit our website is to remember who we're talking to. This is a friend of the show, Francesco Cipollone. He's the former AppSec and Cloud Security Lead for HSBC. He's led cloud security for AWS Professional Services and previously consulted with the United Nations. He's also chair of the Cloud Security Alliance and is kind enough to take a break out of his busy schedule to talk with us. Hello again, Francesco.
Mike, John, always a pleasure.
It's always a pleasure because you bring a lot of, I think, good practical experience to our discussions. And one of the most practical things that we would like to see or see improvements in is vulnerability management. This is something that everyone struggles with. Today, there are going to be at least a dozen new CVEs by the time we finish recording this, I am sure. And everyone out there, all these poor developers are already going to get an email and JIRA tickets of this dependency is out of date, this dependency is out of date, this dependency, all these point releases, and everybody's just going to fall asleep, possibly also during my introduction here, because I'm still talking about this problem. So we would love this problem to go away, but maybe we need to figure out what the problem is, or maybe we need to change the conversation, because a lot of times we talk about prioritization, but I've been talking with you a little bit, and I think John has as well, and prioritization isn't the thing. Maybe we're too obsessed with it. Tell us more about this. I don't want to put words in your mouth. Let's hear from you.
No,
directly.
I think that's great. And maybe on the positive side, we got the 39,000 vulnerability republished from the zero-day project or zero-day today as a historical element, so it will help researchers like us kind of reverse engineer what made a vulnerability a real vulnerability or a true critical. But we're going to touch that later on because I think that's fundamental for the discussion. I think the more I live and breathe vulnerability management, that is a problem that we had for 20 years and more and not cracked it, the more I realize we probably have focused on the easy part, that is prioritization. We have data about it, we have elements, but it's not solving the problem. Like, we keep on having wave and wave of startups that are trying to prioritize to the nth degree. But ultimately, if you don't know who does what where, explain them why it is important, it's kind of pointless. And then how to fix it is the other element. So we try to focus on this sentence only on the middle part. And that's where I think I had the silver lining or the realization or the proverbial bulb on my head saying, we're tackling the wrong problem. And the other two are very complicated. The attribution of assets is typically something that is kind of borderline between security and engineering. But then I realized if we don't have that information, there is absolutely no point about prioritizing the vulnerability to the nth degree, because if you don't know who needs to solve what, where, explain them why it is important, to whom.
Yeah, and that's where, but I want to, we absolutely need to figure out the old school way of handling vulns is, who do I give this checklist to of these things to fix? The modern day should be a little bit, who do I give this prioritized list of risk? I'll hand wave that for a moment. Who do I give to clearly is important. And the hand wavy way for AppSec teams is just say the developers, but you have to find which developer owns this.
Yeah.
But before we jump to that, because that's important, but we've also I don't want to jump over the part of prioritization and what to fix, and are we giving a list, or you use those terms, a little bit more like instructions or recommendations. Mm-hmm. And you mentioned too, like, we do have a lot of data, so maybe quote unquote, it's easier to measure if we have CVEs and CVSS, and now there's EPSS. But you've been looking at this and still trying to figure out what are ways we can even better filter this. Tell us a little bit about that.
Yeah. So we luckily cracked the problem of attribution. That is the problem that we taxed us for years by giving attribution in the hand of developer. As long as attribution is living in a CMDB, no developer want to log in there. So we actually converted the CMDB into a YAML file, and all of a sudden, problem solved. You ask developer to maintain their asset inventory inside their repo. Crazy idea. But then on the other side, looking at prioritization, first of all, I think we have two sides of this prioritization discussion. We have application security that look at really the localized context of an application, but without the other side that is basically runtime, you have a partial picture. So first of all, tracing code to cloud and putting that context together give you a better picture. Is this application in an environment that is externally facing, business critical application? Like, all of these meta characteristics belong to either one side or the other. And if you look at it as a problem atomically or to one side or the other, you don't have the full picture. So you can't really prioritize. And then secondly, we try to go beyond pure CVSS, EPSS prioritization, because I think you have threat intelligence that give you in real time what's bad, what's being exploited. EPSS that give you prioritization in the next 30 days, but it's still partial on some level of vulnerability. For example, for library and application security is a very bad signal because it tends to look at vulnerability that traverse the network. That usually is a very bad signal for a library that is nested into a Tomcat or any organization. Read as Log4j, Spring4Shell, and your favorite shell vulnerability. for those kind of things, I think reachability analysis, but also trying to understand the DNA characteristic that forms an exploit is where we try to focus a little bit more on. The challenge is we try to look at this problem with our favorite LLM, and we realize very quickly the data source that we have for vulnerability are very poor and very small. The description of a vulnerability is very confusing, very small, and there isn't enough context. What are the threat actor? What are the methodology? What are the functions that are getting called? All of this is buried in the advisories or in the research paper that in a way or another are linked by a graph of information around the common vulnerability, the CVE, fundamentally. So we try to develop an algorithm that, together with Google and their LLM, called analyze and really extract a vector of information that was as complete as possible and, very important, not dependent on human to fill those elements. So
yeah, and so let me step in for a second to help set this up, because there's an important angle of why we're talking about the LLM. Because if my initial premise was we're overloading developers with all these dependency versions to patch, are we then overloading humans to figure out, of all of these CVEs, go fill out those CVSS environment scores? Technically, it's possible to express these. It's possible to enrich the data, but as both of you are already laughing at me for proposing that, no human is going to be able to do that well without burning them out. And we've already seen problems with NVD being overwhelmed just with maintaining CVEs as it is. So that's why we're turning to LLMs. And I do want to pick your story back up from there, with the idea is for our listeners to also pay attention to you're applying an LLM here, which sounds appealing for the scaling, for the automation, but I'm going to predict there's going to be some skepticism about hallucinations. Are they getting it right? As well as maybe some budget aspects. So now that we've done the flashback for our audience, we're going to go back right into the action of how Francesco is fighting in our action movie about all these vulns. So carry on.
And I love this conversation, Mike, because you know that I live sometime in the world of research and brain, and sometimes I get convoluted inside these things and assume some stuff. But you're absolutely right. I think there was an element of analysis of vulnerability, and we see on a day in and day out security teams still looking at the CVSS vector and analysis, that is a string that get attached to a CVE, to determine, is this vulnerability easy to exploit, reachable? So they rely on incomplete data to make complete judgment. And that's, first of all, something that we wanted to address. Second, we have AppSec team looking at CWE, or common weakness enumeration, linked to CVE, to decide, is this something that is bad or not, but without having real data about this. So we said, you know what, let's fix the problem. And we also open source a lot of these data to say, what are the weaknesses? What are the root causes that are more exploited in the wild? What are the things that turns into exploitation? And likely enough, thanks to CISA and thanks to few other researchers, we have a good data set of vulnerability exploitation that has been manually verified and declare these are the bad things that you should look out for. So we reverse engineer those. We look at the DNA characteristics with LLM, because for good and bad, LLM are expensive, but they are really good at identifying and working with large contexts of text and predicting these elements, having them steered in the right direction and retraining in the right direction. So it's not, hey, ChatGPT, what is the DNA characteristic of 20,000 vulnerability, or 307,000 as we are today on the NVD.
Yeah, and I'd be curious to learn more about just the using the LLMs, because one of I think last year I was saying LLMs are an AI have been introducing vulns, or developers are using it, and it's causing headaches for security because of code quality, etc. but I've been like, where is AI helping the AppSec side of things? And this is, I think you're starting to touch on this, looking at CWEs, looking at the vulns, but I think too, you are also making the point that CWEs, which congratulations for being one of the few people to pay attention to them. My eyes glaze over when I see them, but they are not necessarily the rich enough data. And I think you also said there's sparse data even for these LLMs to work on, but you're still able to find some success in using this for prioritization. Tell us a little bit more about some of the mechanics of your experimentation and using LLMs from this perspective.
So that's a good question. And I've wrote a book on our journey on retraining Gemini and the journey with Google on how we use different stages of LLM for different functions. Because as I always say, you can be influenced by a tool and become yourself a tool. If you use it without a brain and you say, hey, here's an LLM, let's use it to solve a problem without understanding how LLM works and without understanding what problem I'm trying to fix. And the problem with LLM is they're going to give you a very plausible wrong answer most of the time because they're going to try to please you. And that's the exhilarating factor of LLM. They always going to come to a conclusion, regardless if it's good or wrong. And as a human, we tend to be pleased with that, with the technology that try to please us more than trying to be correct. But that's a philosophical discussion that we're going to leave for later. I think we went through... Sorry.
No, please continue on.
We went through this exercise of looking at vulnerability data and what are the elements that we can feed into an LLM. CWE and weaknesses were something that we wanted in there because really explain the characteristic of the vulnerability. Like you will not see a remote code execution or input validation or code injection into a CVSS string, but you'll see that in a CWE. The challenge is the data set is very fragmented, has been changed over the years, and is incomplete. So if you're looking at vulnerability from 2009 to 2012, where there was the original CVE database, and then from 2012 to 2018, where the CNA or the authorities were released, you see very different data set. And very incomplete data sets where CWE are really just written on the past to 2018 to today, and 50% of the database is incomplete. So 50% of the vulnerability that we deal today, of the popular one, of the 23,000 that are available in the wild, don't have characteristic of vulnerabilities. So we decided...
If that's if that's the case, then you have data that's incomplete, and you want to avoid, obviously, hallucinations. So you're looking at this. How do you look at that data and say, oh, we just have an LLM. We're just going to give it more data, and train it on as much as possible on whatever large data set we can have, or we're going to only use a very narrowly focused that's going to perhaps, we're just going to focus on this set of CWEs that have the word RCE in it, or ostensibly have that. There's got to be a choice there, because here is a situation where you're actually, I think, training your own LLM. So what are the insights that came out of that?
So there are a couple of insights. First of all, we looked at small context of data versus large context of data. Large always win at the input, but not on the training set. Because the data are so dirty, and you have buffer overflow, and different variation of the overflow, the more strict you are with your training set, the worse the output becomes. But it becomes very precise to what you tell them to do. The problem is you assume that you work with same data set. So clean data input, clean data in, and clean data out. And that's what you get. But the problem is you want to fine tune that, and it's more an art than a science at that point, because we tried several iterations and we found a sweet spot where we let the LLM not hallucinate, but infer the information as much as possible with enough training set, so that when it detects specific things like remote code execution, input validation, those are well-written ones. But buffer overflow, for example, is written in 25 different ways. Remote code execution sometimes is written in 6 different ways. So that's where you want the LLM to be a little bit more free. And the more strict you are with your training set, the more it will follow your lead. So the challenge with vulnerability data is very incomplete data. And also, we learned that having a single pass on a vulnerability data wouldn't work for us because it would just give you an incomplete input. So we actually have 7 pass on the vulnerability with an agent that does 7 steps to actually understand what are the DNA characteristics of this vulnerability from all this advisory. But you have a dedicated agent that actually go through every advisory and determine, first of all, is this blog post, is this garbage information, or this actually useful information? And then you have another agent that then extract the characteristic of this vulnerability, and another agent as well that look at the DNA characteristic and predict which one, based on the training set, are more likely to become either a ransomware attack or a well-known exploit. Interesting enough, we train on a lot of data, and we found a data set that completely disagree with us. Can you figure out what data set is that? So we train on well-known vulnerability, CWE top 25, well-known vulnerability in the wild, CISA-KEV, CISA-KEV top 25, published over the years, 0 days from Google and 0 Day Labs, Trend Micro. Which data sets of exploitation, human-driven exploitation, I haven't mentioned here?
It's a good question, because my hope would be the CISA-KEV would be most useful, would be the richest, because that's direct observation of also orgs that we care about or orgs that are consequential being attacked. But I'm going to have to turn this around and say, I'm here the host to ask the questions. I can't answer them. So maybe John, here's my way out. John, I haven't heard from you yet. Do you want to help me out here?
I can't, no. I was thinking the one that's coming to mind is social engineering, which isn't even close to what we're talking about.
Right.
Close.
I keep going.
Bug bounty.
Oh, I was going to. Yeah.
Okay.
Pen test and bug bounty data, and that puzzled me for a while, and I suddenly figured it out. While vulnerability exploitation is a large data set, you don't have any constraint. You present bug bounties only on the hard things to solve, only on a constrained data set. So it's not the complete picture, but it's actually a very constrained picture. And we found some gaps and overlaps, like remote code execution and buffer overflow are high. But the data was not confirming extensively how much we found on other data sets. So we tend to exclude that data set because it kind of measured up the waters, and we thought that we could come back to that data set because maybe it's incomplete or maybe it's constrained too much.
But what's interesting there, because bug bounty is also it's also one of the few ways we actually can quantify risk, in the sense of this bounty was a $100 bounty, but this one was a $10,000 one. Here's a $15,000. Or if you get into the Googles and Apples, you can easily break that $100,000 bounty threshold. So, and that seems to prove that there is a problem that the company acknowledged and went to fix. So that's interesting that's either excluded or as you said, or didn't mesh with your original research or how the LLMs were looking at this.
Yeah, and we published the research and we published some of the data. So if somebody can figure out a better way, that's why we love open source research and data, because we want to collaborate as well with the community to actually crack these nuts. That is prioritization. But this fundamentally helped us to forecast the probability of specific DNA characteristic to become bad. And the beauty of it is that they don't need to necessarily be CVE, but also we can apply that same logic on CWE and usually on AppSec data. So we can predict a remote code execution is it likely to be bad, but based on threat intelligence, that usually was a very difficult thing for us to do, because threat intelligence data usually apply to CVE, OS, traditional chassis or platform level vulnerability, rarely on AppSec data. And that was my joy and happiness because we can apply some rigor on saying, is this bad? And do we have data about it? And can we use that data to create a risk-based narrative that is actually solid? Because you can argue with people and opinion, but it's very hard to argue with data.
So we're talking a lot about the training side of things. I'm curious, how do you validate that the LLM is doing what it should be doing?
You retrain or you retest the validation set against your initial input set. So you see how close you are, and you do a several iteration so that you'll determine if the answer that the LLM gives you is closer to the data set that you retrain the LLM. And there is a little bit of bias. So in theory, we should have a larger data set, and we will continue improving the data set of retraining and revalidating. But that's usually the method how to kind of take a data set or a sample data set, train an LLM and see, are the answer hallucinating, going a completely different direction, or coming close to the original set?
Does that vary? So I get what you're doing. You're taking a subset of your training data and using that for validation.
Yeah.
Does in some cases when people do that for machine learning, tends to be a divergence between the training set and what happens when it goes out to the real world? Or are you still seeing alignment there? Or?
We see consistency more than alignment. So we see that the things that the LLM spits out, especially with Gemini, because it's trained to stick to your data set as much as possible. And we can go and talk about that for the nth degree on how we choose Gemini versus OpenAI versus Cursor. I think we start seeing the specialization of the various LLM engines. But yeah, we saw that with this particular LLM, the output rigor was higher. And that's why I mentioned before, we wanted a threshold of data that was kind of in between the full data set or a partial data set, to still allow the LLM to infer some information, but still stick to a good set of data or a good answer, or an answer that was logical. Of course, we didn't test that on the whole 300 vulnerability data set, but on a 5,000 data set output.
Yeah. And a lot of this work is available, I do want to emphasize, as open source that people could participate, they could review on. And we'll make sure to link to the repos to be able to review this. One of the things I want to get to is this aspect of training, what the LLMs are telling, what decisions it's suggesting to take, is that you're talking about like likelihood or the exploitability or probability. One of my jokey complaints about CVSS is how much do you care about a CVSS of an 8.4 versus an 8.5? Do we care about those decimals, or do we just care about this is an 8, or this is a 1 through 4, this is an 8, 9, or 10? And I think here, I don't, at least I hope, it's not the aspect that the LLM is coming up with a probability that this is 72.3%, like the magic computer for like Ziggy for in Quantum Leap
42.
For deep cut sci-fi nerds. Yeah, exactly, 42. So how do you know that? And this is a follow-up on John's question too, in the sense of you've trained it. How much have you? What's your confidence that you haven't overtrained? And how are you having the LLM give feedback to an end user that is more than, so the end user that doesn't have to figure out, well, this is 42%, but I only care about 43%, so I can ignore this, right?
That's the point.
Yeah, how do I make the decision on this?
It's giving enough information so that the end user can judge on like, this is high, low. So we actually completely remove the percentage, because people are bad at percentage and probabilistic analysis in general. How high is a high or how low is a low? You can argue on this. And ultimately, this, I want to go back to the original element. This is a piece of the cog. This is one of the cog. We didn't want the whole platform or the whole research to be about prioritization, because then we obsess about the problem that is not the only problem. So this was a stepping stone for us to create a good enough vector analysis so that we can pass this vector element to the second agent that was the analyzer to actually derive might run attack threat scenario or stride, depending if you're working on AppSec and so on, and passing that context together with reachability analysis and localized context to the crown jewel that is the remediator. The whole purpose of this is not to come to the 8.7, to the 4.2, to the 1 score, but it's to give a complex enough information to an agent to derive how can we cluster this vulnerability together? How can we fix this vulnerability together? And we found that you have multiple vulnerability resolution methodology. If you're in OPSEC, you want horizontal remediation, like you want to fix a software across the entire ecosystem, or maybe a number of softwares based on the remediation element. If you're in software, you want to focus on a library, on a build file, because the effort to fix a library across many build files will require a lot of teams, a lot of coordination, and a lot of regression testing. So suggesting what is the best remediation action and fix is different from every type of problem. Container, patching, and software are three very different beasts. So
and that's what's
appealing. Where LLM are good.
Okay. And that's why I wanted to ask, because on the one hand, if we're just saying we have an LLM that's going to give us rewrite the context of CWEs, CVEs, everything that you listed off, and then giving the developer, we're not going to give you a percentage because 83% of developers have trouble understanding percentages. That feels like we're just giving them different information that's not helping. That's just a different way of overwhelming them. But if you're describing, here's some remediation, that suddenly becomes a more appealing story because you're saving them time. And I know we're also short on your own time, but maybe if you could give us a little bit more of that, another peek into what you mean by that remediation. What does that look like that where an LLM is actually helpful here?
Yeah, so the first part of remediation is first of all determining who is touching the code so that we can cluster even on the same people that are touching the same code. So attribution is always the cornerstone, is the first step of this. The three agents, the researcher, the analyzer, and the remediator then collaborate with each other to actually derive to that remediation. And we cluster, or we create three clusters, depending on who you are, to create three different remediation action. And this is still in development. We're still discovering new way, because we produce with the agent's remediation plan, and some of this remediation plan makes absolute sense. Like for an operation team, this is the patch, or this is the group of patch. Like you have Mac OS, and this is the group of patch that's going to fix the majority of vulnerability and are going to give you the majority of risk reduction, or the best path to remediation. And that makes absolutely sense for them. But if you go to an engineering team and you say, this is the library that you need to fix across 200 build files, and 15 of those haven't been touched for like 20 years, they're going to say, you're mad.
Good luck.
But if you tell them, look, you have this build file, you have, for this particular library, you have 5 versions, and this is the best version that you're going to go through, and this is a pull request that already take into consideration a lot of this, and all you need to do is accept, test it, and proceed. You reduce to the minimum the decision and the brain power, and they can just build it and test it, and chances are that your remediation time is going to go dramatically down, because you give the most important vulnerability to the more accurate team with already the remediation in place, so that they can just click and fix and determine if that fix is going to break something. And likelihood is that they're going to carve out time for that, rather than, hey, this is a list of 2000 CVE, compare it to this 2000 container in this environment, figure out which one is yours, and once you've done that, determine which one needs to be fixed that is more important. And by the way, the CVE disagree between these two tools, and then do the regression testing and allocation. At the first minute I've dedicated on this, they disappear. So our scope is to give is to specify the remediation of the most important vulnerability that the engineering team can click and do, or the operation team can click and do. So we want to do the heavy work so that engineering and security can go back to doing what they are paid to do, that is using the brain and not using an LLM for the brain or outsourcing the brain for an LLM.
Yes, and we'll let you go in 1 second, but we're going to have one more use of your brain. But I did just like to repeat that idea of that attribution is figuring out who's the one who's the team, the person who has the best context and the responsibility to read what you were just describing, a list of like remediation, or here's the patch, here's the pull request. And that feels like, I'm going to be a little bit hand wavy, apologize. That's the language of developers rather than trying to educate. This is what a CWE is. This is CVE. Here's the EPSS. All of that is a different language. Is honestly unnecessary. Yes. Thank you. And so much of AppSec can be meaningless, but you brought us some good meaning, I think, in this quick 30 minutes, Francesco. And as promised, we do need to exercise your brain a little bit more. At the end of every interview, we always ask our guests to describe AppSec in 3 words. And so you already used "you're mad" as one kind of response, but that's only 2 words. So help us out here.
So I have 2 versions.
Okay.
I have one when I started working in AppSec that is, oh my God, is a bloody mess. Sorry for my Britishness here. And then I just realized that this year, with the advancement of technology that we have a better way. We finally have a better way to crack this problem. And I will just rephrase that sentence and say, it's complicated, but there is a better way.
It's complicated. Okay. It is complicated, or there's a better way, or a better way. You got to stick to 3 words.
It's both. It's complicated, but there is a solution.
Okay, this is the problem of trying to talk to an LLM and deal with math.
Exactly.
Yeah. But thank you, Francesco. This was a wonderful conversation.
Mike, John, and everyone, thank you so much for the time. It's always a pleasure.
Thank you, and thank you to John as well. Thank you, everybody who's been listening. We're going to take a quick break now and return with news of the week. Ransomware, supply chain attacks, 0 days. Cyber threats don't wait, and neither should your defenses. With ThreatLocker, you're not just reacting to threats, you're stopping them before they start. Our Zero Trust endpoint protection locks down your environment with pinpoint control over what's allowed to run and what's not. No guesswork, no blind spots. Just proactive, built-for-now security that keeps your business moving. Want to see how a true default deny strategy works? Head over to securityweekly.com/threatlocker and take the first step towards shutting the door on threats before they even knock. Welcome back to Application Security Weekly. We just talked with Francesco Cipollone about expanding the conversation on vulns from prioritization to a focus on remediation. Why don't we fix the things, but even better, fix the vulnerability classes, avoid vulns altogether. And there's a lot of that conversation that we needed to continue. We're stuck on only 30 minutes. It makes it tough. But I'm your host, Mike Shima. I'm stuck here for 30 minutes with John Kinsella. He's going to make it tough to get through the news, but John, we got to do it.
Okay, fine.
Oh, that was an easy if only like vulnerability management programs. John, you got to fix these 1,000 dependency vulns by the end of the week. I don't think I'll get the same response.
Might have a different answer. Yeah.
Yeah. Let's keep it. Yeah, we don't want to get a strike on our YouTube, so we'll avoid that topic and switch to another one that might get a similar answer, which is supply chain security. So there's definitely a theme of supply chain this week in the news, and I'm going to start off maybe small and random, because this week is also brought to you by the letter R. So here's something from the Rust blog, crates.io, malicious crates, faster log, and async print line. So basically, there was call it typo squatting, some sort of an attack. I don't care to classify it right now, but Rust and crates.io is not immune to malicious packages appear and bad things happen. Let's see. What was the interesting thing to me about this? I think it was more of just really that there's an aspect that Rust is not immune. So we talk about memory safety, but memory safety isn't the end of the security journey. And I think, however, that it is interesting to see, how am I trying to phrase this? How Rust responded to this. but I didn't read Rust's take on like their philosophy on supply chain. I wanted to, and the reason I was bringing that angle up is I was reading about Go's supply chain security philosophy, and they're very much of the idea of our package managers don't have post-install scripts. Basically, here's a package, and it just so happens every package, like NPM, that's full of JavaScript, for example, also runs a shell script. Crates does not do that, which that also run a shell script. But in this case, it was showing that these malicious packages still worked as loggers, but just so happened to siphon off and exfiltrate some private key, basically cryptocurrency keys. That's where there's money. So, and I'm going to come back to the idea of here's our package that just runs a shell script as well. Basically does some surprising things or has side effects. But rather than me just cause some side effects of on our listeners for talking too much, John, we got to hear from you. I think you've been playing with Rust a little bit. Any malicious crates so far that you've installed by accident?
Excuse me, not too much right now. My coding's been more Python the last few months. We use a lot of Rust, but not so much me personally. The first thought was, I don't know, just the headline on this, the title on this blog post alone feels about as readable as Rust is. It has a bit of that sort of like, I don't know. It's an open and shut case, right? They found it, they deleted it, they suspended the users. Have a nice day. And then like a little bit of a breakdown on what the code was doing. And the thing is, like, you mentioned, there's potential, technical phrase, potential badness by letting a package manager run a script on your local machine. But you're downloading code and you're going to put that into your application, which is going into prod, which is probably a lot more scary than running a script locally in a lot of cases. This feels pretty targeted. They're quote unquote just looking for crypto keys and stuff like that to exfiltrate, but that's a pretty small percentage of folks out there, I'm guessing, compared to like where Rust is being running. I mean, I'll foreshadow to another article about a network which is using Rust. I doubt they're got any crypto that they're running on those systems, right? So,
yes.
But yeah, it's
yeah,
one of those problems doesn't go away.
And to your point, the blog post from socket.dev, which identified these two crates in the first place, noted that these crates are pure Rust and depend on only the Rust's STLs, plus request, another request with a W, another Rust. For you Rustaceans out there, basically means that the behavior of these malicious crates is identical on Linux, Mac OS, and Windows. And that's kind of cool when you have write once, run many places, run anywhere for your malware. Now, I said there was a theme of supply chain. So before we get to the other article you were foreshadowing, let me pull in a little bit of drama, a little bit of focused planning, and a little bit of stewardship. So the drama comes from here's an article that I highlighted: Shopify pulling strings at Ruby Central forces bundler and Ruby Gems takeover. Reading through this, it to me was reminiscent of the WordPress saga that happened, I think, last year, which was basically the .com side gets involved on the .org side, and you have a corporate interest that very clearly in the WordPress case was using security as a bludgeon and as a fig leaf, if you will, to forcefully take over some WordPress plugins. That was very much an abuse of security. Here, I don't want to say it's the exact same thing, but at least on the surface, the community is responding negatively to a corporation coming in and saying, hey, we got rid of a bunch of your owners of this repo, and we're taking over. And for the good of the community. This isn't quite like the whether they had good intentions or not. The highlight I wanted to bring out of this was that as these types of ecosystems get bigger and more mature, or their adoption becomes more consequential, they absolutely need a strong governance. And both on a technical leadership side, who's making decisions on prioritizing features, et cetera, as well as an organizational leadership. And I wanted to call out the organizational leadership because that's where you would get better communication about this is why we're making this change. This is what we expect to see from it. And ideally, you would get some transparency about how the change is going to be made and how it's going to be staged. So it's very much there could easily be security dimensions to this, but it's very much not a technical security conversation that this type of situation requires. And I think that's also kind of a reminder to our fellow AppSec folks out there who are saying, hey, go fix all these vulns. It's not just a list of vulns to go fix. You have to have a conversation.
It feels like I'm missing the backstory on this. It's like, okay, this stuff happened, but like, this is a pretty severe action to take. You would expect there to be a story of like, hey, for months and months, we had something going on, or people weren't responding, or we saw these things keep getting compromised or something. And it just feels like they went bam, straight into it. And yeah, so if I can see for a casual observer, which I'll consider myself here, yes, I'd react strongly. Ruby is one of those things which I also use that in part of my org, I'll say, and I would love to get away from it. It's not going to happen anytime soon. But yeah, so yeah, anytime, if any of these things we're talking about, these supply chain packages, systems, if any of them had some sort of strong move, I'll say like this, there's going to be strong reactions. And usually what this is based around is when we come up with these systems, initially we don't think, hey, if there's ever a case where we need to, I don't want to say take control, I'll say provide governance, strong governance to a package. How do we go about doing that? And most folks aren't thinking about that till it's too late, and then they go and they do this, and nobody knew of any sort of standard or anything about it. Like, wow, I never you guys would even consider doing that. And maybe it was for the good, but the next thing, there's a lot of teeth gnashing going on. So unfortunate.
Unfortunate. And I can add to the link, there is a discussion from at least 2 weeks ago about Ruby gems attempting to improve their governance and write it down. And I pay attention to this too, because I read Daniel Stenberg and the curl blog, and they actually have a lot of strong governance around curl that speaks to what if we have a vuln, how is this more than just Daniel for the project to continue to be maintained to make decisions. Let's keep this article in mind, and let's hop over to another article from GitHub about our plan, GitHub's plan for a more secure NPM supply chain. Now, if the Rust blog title was a bit inscrutable and Rust-like, and people are still kind of scratching their head, what does this mean? I think this is a title that I'm hoping everyone and there was much rejoicing, is going to be my pop culture reference to a title like this. Because yes, we would like to see a more secure NPM supply chain, because this article mentions the Shai-Hulud attack, but we can go every single month. There is this many hundred or this many thousand malicious NPMs packages that have been uploaded that people are downloading and getting hit on. This one focuses pretty much just on authentication. And it's, it speaks to me. Hey, use FIDO, don't just use TOTP 2FA. That's cool. And I don't want to just say that's it. And they're not saying this is all we're doing. But I'm just struggling to say I'm wanting more. I want more out of this. And I don't know, how did you read this? Or
the question I was going to ask you is, were you one of those people who had much rejoicing? And yeah, it's okay. This is our plan for a more secure NPM supply chain. Cool. As you said, local publishing with 2FA, granular tokens, and trusted publishing. That it sounds nice. And then we started digging a little further before we're talking on air. At least I did. And did I close already? I did. But on the trusted publishing, they quote from a line in this: the goal for trusted publishers is to reduce the need for long-lived tokens or credentials to be shared with external systems. Mike's already heard me read this once. When authenticating with package repositories. Okay, cool. So your way you're going to improve the security of NPM is by getting people to stop using personal auth tokens, basically, sort of what it sounds like. It feels like there could be more there. So, and I get it. This is, as I, when I think it was beginning of this year, I was saying I'm hoping they do something. So thank you guys for listening to me. But in seriousness, one of the things I brought up then is it's such a big ecosystem. You can't have humans in the way. It's like, so the question comes down to how do you improve the trust of what you're providing to your consumers? Can I trust every package I get off NPM? Do I know that it's not going to get hijacked and have malicious code put into it? Am I going to get a package which is typo squatted? There's some really common problems here, specifically to this ecosystem due to the size and I'll say varying degrees of experience in the people that those consumers. I'm going to mark this as a start. I think there's a long way to go. Maybe they can get some of Francesco's LLMs and actually help put some of this stuff here. I say that partially jokingly, but yeah, to me it's just, well, actually one bullet caught my eye. Immediate removal of 500 plus compromised packages from the NPM registry. Yeah. So they're getting some stuff done, but 500 out of how many? I'm guessing that's like a fraction of a percent. There's probably a lot more to go.
Yeah, and I think there is the success metric here is, apologies for getting a little corporate speaking, is that what is the adoption of the trusted publishing, or rather than just saying, oh, this is the NPM that Mike owns or this individual owns, there is some cryptographic backing that just says this is a known entity that built this package through a known set of steps that have at some point in time have been vetted and are considered secure, which is helpful, I think, for just getting rid of that class of attacks where a package maintainer gets compromised. So now you have to compromise the build environment, the publishing environment, rather than just the maintainer, or you can't just publish from a non-main branch, some point version or some commit branch or feature branch, and that gets pushed out as a package. And I think this is kind of what it's alluding to, which is good for getting rid of a class of vulnerabilities, but there's, as you were already saying, there's lots of classes of vulnerabilities out there to deal with. So that's the build up to, here's one final thing on supply chain, then we can move on. John, I have here from OpenSSF, open infrastructure is not free, a joint statement on sustainable stewardship. And I think this does tie into the concerns around, I made that allusion to WordPress.com and WordPress code, as well as that Ruby article that we covered. Go and Rust have, I'll say in my observation, pretty strong stewardship around their ecosystems. And we saw this statement or what GitHub is doing around NPM. And so they're taking on that stewardship. The catch with GitHub is that corporate entity, pretty well funded. They know where their funding comes from. What this is saying, there's a lot of open source out there that is being used by commercial entities. And there's a impedance mismatch, to use my electrical engineering background, between how much corporate and commercial use there is versus how much responsibility is putting on volunteer time and personal time. And I think that's kind of the takeaway from this, or maybe at least a takeaway.
There was, I'm looking for it. There was a line in here I liked also. You're just trying to make this whole thing more corporate honest, Mike. I'm not quite sure what's going on with you today.
It's the end of the quarter. Yeah, I got my KPIs.
There was a line in here talking about, like, these are, projects which people work on their weekend in their spare time and out of love or interest, or it's volunteer work a lot of the time. And how do you, what interesting in my mind comes down to is, like, because I remember back when I was doing Apache Cloud Stack, I came in at one point, like, very sort of like, the security guys here, let's fix things, and that got no traction. And I've learned since you have to do that dance when you're working with open source teams. But that versus here, right? Like, the people who are working on these, what it's coming down to here is the usability of security. for this or the NPM article or for any of these. But like if I'm working on something on a Saturday and I just want to like check in some code and like, I see a bug in something that people are using and hey, let's fix it. Or I got an idea for a great feature, right? These type of things. You want to be able to make that possible, probably more so than for your professional software developers, right? Because you can say must do A, B, C, and you have to have the musts in an open source project. But how do you? It has to be a more, I'll say, well lubricated process. So that's not free, and I think that to me is where the interest is of like, hey, can we get people contributing to this? Preferably organizations contributing money or resources. And hey, another idea, maybe someone orgs out there, you have a security team, go and volunteer for like, 5 hours a month each or something. And there's lots of ways to do this, but it is a good call out. We'll see what comes from it.
Yeah, and maybe this is the line that you are looking for that might appeal the most, is that the, quote, commercial scale use without commercial scale support is unsustainable. And that's really the gist of what this is saying. And to tie some of your comments there, the subtext, I think, or a subtext of that GitHub article is that, hey, everyone use Fido, but the responsibility should be on GitHub to make sure that adopting, onboarding to Fido is easy within that ecosystem of how they're demanding, and paying attention that a lot of people are going to potentially object. We've seen this on a small scale, admittedly, but we have seen people be like, oh, there are privacy consequences here, or there are identity consequences. Do you want the real human identity, or do you want my pseudonymous presented identity? But as long as you know that this is the owner and they went through some secure steps, that's probably good enough. And I think that's what the gist of trusted publishing is going for. It's not just saying only Mike can do this because that's Mike and we have it identified in Mike.
Yeah, sometimes we want to know that this is coming from, I don't know, what's a brand around here I haven't picked on for a while? I'm looking for something in my room. But like, some sort of Joe's widgets. Sometimes you want to know it's coming from Joe's widgets. And this is the official package from Joe's widgets. And sometimes you just want to know it's that person who's been working on this project for the last X months or years, and it's not some random who just started contributing to it. So yeah, I get what you're saying there. The line in the OpenSSF article was billion-dollar ecosystems cannot stand on foundations built out of goodwill and unpaid weekends. Completely agree.
Yeah, and that's where just one final comment there. That developer experience applies to are you the AppSec team parachuting in, or the security team saying we have all these concerns, jump through all of these hoops to make to address our concerns? There has to be a bidirectional conversation there. Mm-hmm. But let's switch to a different type of bidirectional conversation and get out of supply chain. And there was much rejoicing, into a little bit of non-LLM articles. I've got 2 or 3 more articles, John, that have nothing to do with LLMs. And part of the reason I grabbed this Trail of Bits item was taming 2,500 compiler warnings with CodeQL, an OpenVPN2 case study. I've joked in the past, and we can discuss how good the joke is or not, that so many AppSec tools are really just grep or fancy grep. And CodeQL is a good example of, admittedly, a very fancy grep. But what the challenge here from an AppSec perspective is that you've got CodeQL, you can scan a whole bunch of code, but if you're getting 2,500 hits, how many of them are actually security consequential? How many of them do you need to pay attention to? And what was really neat is that this walked through the technical steps of turning that original grep, look for this type of signed to unsigned comparison that your compiler is always going to complain about. And if it's doing this, conversion, is it doing this conversion in an insecure way that's potentially exploitable? Or is this is just we could have our pedantic and improve our casting of integers that everybody's going to fall asleep to if I start to get excited about that. So long story short, it's really neat how they walk through and say, here's how we went from 2,500 hits down to a few, about 1,000, down to about 500 or 700, on just eliminating different scenarios that the CodeQL could very predictably and deterministically do based on the AST that is inspecting. And long story short, it boils down to conversions involving user-controlled data, which are the most likely source of exploitable vulns, because that's how you play around with length fields, et cetera, to get these conversions to happen. And I just thought that was a really nice way to show here is work using old school, if you will, tools for doing human review. So yay humans. That's really just all I wanted to get to. So we'll just edit all that part out and say yay humans.
It's only 2 words, Mike. You need 3 words.
Yay us humans.
There you go. Yeah, this is it's a pet peeve of mine in a way. Sort of, they're approaching this problem from it's a good way they're going about it. I like the write up, but a pet peeve of mine is horrible trash compiler log messages from any of them. Right? Go used to be horrible. I think they've gotten better. Yep. Pretty much pick a language. Anyone listening to this is, if you haven't had a horror story, try and figure out like, what does that mean? You're going to at some point. It's something I internally, when I'm talking to some of our junior engineers, I'll bring it up pretty common. It's like, I'm sure I've started to hear before, like the 3 o'clock in the morning problem. Like when you're writing an error message, I know it's not always easy, particularly for a compiler, but how do you make that thing as readable as possible? Like, or in this instance, should the compilers be saying, hey, this has security implications? Or is it just, should it be providing commentary? Maybe not, but it's just a question I'm throwing out there. Or should it be dry and hopefully accurate? So yeah, I'm glad they did this. It could have helped me quite a lot many times. But.
Yeah, and I hadn't thought about the readability, because I'm on team -w all, have the compiler complain about as much as possible. But I have to be quick to acknowledge that even with this like conversions, you can start then to suppress and get rid of a lot of those compiler complaints by throwing in a lot of decorations. Here we're casting it static cast and dynamic cast and all these things to uint32 and blah, blah, blah. And I can just pretend I remember C++ by saying a lot more, things like that. But does that code? Yeah, exactly. But human, like that's great for the compiler, but then you start to lose the human. Are you helping the human who is looking at that code at 3 a.m. or for whatever reason? And that's where you get into something that's a bit more subjective about too much of that syntactic sugar, so to speak, or even just getting into, hey, TypeScript. I love the idea of TypeScript in bringing strong typing because it can prevent subtle errors, or at least highlight subtle errors is probably the better way to say that. But wow, it can be a bit confusing, and there's a barrier to entry in terms of reading the code.
A little bit like Rust in a way too, though, right? It's that same sort of, not quite the same, but similar ideas you're going for there. It's also making me think about that story we had from last week where, I was talking about your code review completely is separate from the code itself. Should those be merged together? So I think there's I'll say a picture here of a potential future where your code is, or I won't say your code, the code for whatever, we'll go back to Joe's widgets. For the latest version of Joe's widgets, could be the future version of Joe's widgets, could be this very descriptive, a lot more than dry code, right? It could be talking about how we got here. It could be talking about what this data is. Could be talking about really sort of, I don't want to say metadata because that doesn't feel right, but the theme and the intention of what we're trying to get done, not just the for loop itself. So I don't know, that it appeals to part of me. I haven't tried writing it that way, so when you actually do it, it might be a lot different. But the future could be bright.
Future could be bright. And speaking of things that appeal to you, I was curious. I thought this Cloudflare blog post about Cloudflare just got faster and more secure, powered by Rust, might appeal to you because I fall on I far too often fall on the side of, let's refactor, let's rewrite code, because I like the idea of rewriting code, rethinking, and just learning about the code base. But what this article is pointing out is, and I think what John has pointed out in the past, ain't got time for that. If I can do my John impression, refactoring for the sake of refactoring, even if we're going to say, hey, like an AppSec perspective to say that's C and C++, go rewrite that in Rust or rewrite it in Go. Memory safety is important. Okay, that's fine. But it is extremely unhelpful as a bit of a callback to our conversation with Francesco, to just be like, go do this because I said so, just for the pure sake of security. And what this blog post walks through is, yes, the refactoring and performance is probably number one, but a very close is security as well, because security and more secure code helps one with performance as well as their reliability and resiliency. Before I get into some more of that too, though, we were talking a little bit about languages and in writing and readability. There's a great reference here about roughly 15 years ago, this FL, Cloudflare, this internal project is being rewritten, started out in PHP. So it was Nginx with, quote, product logic implemented in PHP. So all of those language wars that we could have fun with, doesn't matter if it's, generating revenue. So that was what I wanted. That was the first thing that was fun. But John, I wanted to check, are there aspects here that do appeal to you in the sense of my understanding of your stance of, if you're going to rewrite, you got to have a plan, or there's got to be a reason?
Yeah, these things are expensive, right? I mean, if it's one thing for them to show their Git commit headers, that's cute, and really it's just cute. But show us the how long did it actually? I can't remember. There's one more in here. So FL2 started July 10th. Last year, so it took them about 18 months to do this rewrite, one could say, or probably a year, and then a lot of testing. That statement there alone, how many people were working on this? It probably wasn't just the one dude or person, guy, girl, whatever. But yeah, I can guess what these guys went through. You can probably sort of hear the pain in my voice, because you're not re-implementing a standard. You're re-implementing the thing which exists. So that means when something like this is working at scale, if someone out there in, I don't know, the middle of, let's say Azerbaijan, or get out of the US, pick a different country, someone out there somewhere is going like, they've figured out a way to use Cloudflare that worked perfectly for them. It made their service cheaper. It's really fast. It works for the people in their community, but it's on something that was undocumented on Cloudflare's part, which just happened to work. When you re-implement it, you have to be, or at least this is my current org's point of view, you have to have that ownership of and the trust of the customer experience. So you have to re-implement the exact same way it was before, even if it was broken. Mm-hmm. And that's where the testing comes in of like, okay, how do you roll this out? I know that they talk a lot about how they roll it out too, but how do you make sure what you've got is the same as before? So in theory, you've got to sort of test with customer data somehow. There's ways to do that safely, but still. But yeah, so my point is it's a really expensive thing. And yeah, you have to have a goal in mind. Like, we were talking about KPIs before, something like if you're going to start doing this, what am I going to get out of it? What's in this for me is what it comes down to. Particularly for a public, I think they're a public company.
Yes.
You kind of have to, what's this going to do for my stock price? I hate it too, but that's the world we live in. So yeah, it's interesting that they said this is what's in the first stock price. We're going to use less machines or make it faster, have customers love us more. But the one thing that sort of caught my interest in here, if I'm reading this right, how do we measure if we're getting better? There's a graph there where a big drop goes from 35 somethings down to 20 somethings. We're talking about milliseconds. Looks like you're 50th percentile. And then there's some camel humps. As it looks like they're probably doing software deployments. That's what it is. They're doing software deployments on weekends. Because I was going to say the 3 humps on there where the latency increases, I know this is not AppSec related, but it just caught my attention. It goes up, not down, in 2 or 3 points. And I was looking on the calendar, they're weekends, and usually you have less traffic on a weekend, right? And the diurnal pattern is usually more weekdays, depending on what site you're looking at. But if they're doing software upgrades in the weekend, I bet that's what it is. So it's slowing down, then the next week it gets faster, and they do another one, and then it gets faster again. Answer my own question. Okay.
No, that's great. And 2/3 of this article is very much about how do we migrate to this FL2 with preserving everything you were just describing. And that's why I wanted to highlight this for our AppSec folks to read and appreciate, like, what are the considerations for developers to migrate, to get rid of a legacy, to go from a legacy system to a new system, to rewrite a system, or just to change any software that you're asking for from a security perspective. And it's really neat to see how they talk about, here are ways we don't have to tear down connections can gracefully end, and then we update the software. Talks about other benefits of just going through a unified code base, even though they were using Lua, for example, which is, hey, there's memory safe already. But it had to go between Lua and C code. So there were all these boundaries that just became simpler. So there's also the byproduct that it sounds like, I think 100 people or so, they say, were working on this, is sort of a point to what you were making too about the effort involved. But it sounds like the code base is shrinking. And so, to quote, FL2 was substantially faster than FL1. The biggest reason is it performs less work. Basically, it has to do less, burn those fewer CPUs to be able to preserve that behavior.
But just really briefly I want that to sink in for folks. It probably wasn't 100% of the time for that 100 people for a year. But let's imagine that Cloudflare found some really cheap, really great engineers somewhere in there, $100,000 each salary. And I'm off probably by at least 2x, but let's keep going. So you got 100 of those guys for a year, $10 million to do this rewrite. That's not pocket change, even to a big company, right? You have to really believe in what you're getting out of this to do that. So kudos for doing it and hopefully pulling it off well. And again, as I was saying, this is a HTTP proxy, right? So anything, all the bugs and all the trash we've been talking about for the last few years in HTTP, HTTP2, you have to be able to reproduce those. And if it works before, it'll work again. And it's well done.
So, so I think KPIs, we've been mentioning that. Of course, that stands for key podcast influencers like you and I, Mr. Kinsella. Yes. And but we don't have to be the only one influencing out there. The whole community of AppSec folks can help OWASP. They have an OWASP Top 10 2025 community survey that's open now through this Friday, I think, if I have my own calendar math correct, through October 3rd. So if you want to influence the future of the OWASP Top 10, like both John and I might, take a look at the survey, give a response. And just to give you an idea, just asking for your years of experience, sort of what's your role, builder or breaker, what's your rough title? And then John, maybe I can ask you this. I'm not sure if you want to reveal on air, but it does ask the top 3 important risk categories that you would like to see in the 2025 edition. What's in there?
You already heard me comment that I don't like how they've done this. 1, 2, 3, 4, 5, 6. So there's 6 different categories. And then, this is someone who's a fan of, let's see how this gets you to respond. This is someone who's a fan of ranked choice voting. You can tell how much I like that because I can't even get it out of my mouth. I just find that to be too complex. For those who don't know what I'm talking about, consider yourself lucky. An idea, it's perfect, great idea, but this is just something about how they did this. So let's see. Number 1 for me was software supply chain failures. Number 2, I shouldn't be saying this. I'm just going to give everyone ideas on how to vote. Number 2, memory management errors. That probably should have been number 1. And then 3, I put software data integrity failures. So those are my top 3.
Couple comments on what you were just saying. Notably, as a callback to our conversation with Francesco, each of these categories has at least a half a dozen, if not more, CVEs associated with them. So I find that just interesting in the sense of InfoSec loves to have so much taxonomy that, just more taxonomy. But sorry, my number 1 is path traversal, completely missing from this list. So I'm just missing it out of hand.
That's your write-in.
But yeah, that's my write-in. But as someone who plays D&D and is trying to figure out, hey, when can we next get together? I very much embrace and love ranked choice voting because that's the only way to find get a handful of people together these day and age. But I was happy to be able to regularly meet with you on a Monday morning, John, to be able to talk through this type of AppSec.
Pleasure's always. Sorry we didn't roll any dice.
We'll roll some dice next time. But thank you for joining me regardless. There's some diceless role playing out there as well. Amber for another deep cut for you fans who may even know what I'm talking about. So for those fans who do know what I'm talking about, thank you for suffering through. For those others, thank you for suffering through. Please remember to subscribe. Check out the show notes. Share about us on the socials. And speaking of D&D and scary things, check out Nightshade by Occam's Laser. We'll see you next time on Application Security Weekly.